Hello everyone. In this video, we will learn how to find domain and range of different types of functions. When we talk about functions, it is very important to know for what values of x function is valid and for what values of x function is not valid. This leads the concept of domain and range. Domain is the largest set of all input values x for which function is mathematically defined. We can say domain has all allowed values of x, all possible values of x. Range is the collection of all possible output values. All possible output values of the function, or we can say it is the set of all images. For example, look at the diagram here. The domain is the set x1, x2, x3, x4, set of all these points. And codomain is, you see, set of y1, y2, y3, and y4. If we talk about the range, what is the range? Here range is the set containing y1, y2, and y4. But here y3 is not the image of any x. That's why y3 is not included in the range. So clearly from here we can see range is a subset of codomain Y. Now important question is how to find domain and range of a function. To identify domain, we always try to find restrictions on input values x. Let me summarize possible restrictions on x for some functions. First, for polynomials, there are no restrictions. They are defined everywhere. Means they are defined for all real numbers. So domain for polynomials will be set of all real numbers. For rational functions, denominator must be not equal to 0. So this is the restriction for rational function. If we talk about even root functions. So for even root functions like square root function, fourth root function, the inside expression must be non-negative. So here we write that inside root it is greater than or equal to 0. For odd root functions like cube root function, fifth root function, there is no restriction at all. They are defined everywhere. They are defined for all real numbers. So domain for odd root functions also set of real numbers. Now exponential functions. These functions also always well defined. No restriction here. So domain is set of all real numbers. Logarithmic functions are well defined for that argument of log must be strictly positive. Means we can say that inside logarithmic it must be greater than 0. If you talk about the trigonometric functions, first is sin x. Sin x is well defined always. There is no restriction. So domain is set of all real numbers. Same for cos x. No restriction. Domain is set of all real numbers. Trigonometric function sin x. It is undefined when cos x equal to 0. So restriction for this function is cos x must be not equal to 0. For composite or mixed functions, we can apply all above rules that we have defined for polynomials, rational functions, even root functions. odd root functions, exponential functions, log function, and trigonometric functions. So based on this, we can evaluate the domain for mixed functions also. Let me discuss some examples that how to find domain. So I am taking one example. Suppose function is a polynomial x square plus 3x plus 2. So we see that it is defined everywhere. It is defined for all x. So there is no restriction. So for polynomial, that's why we say domain is set of all real numbers. If function is rational function, it is 1 by x minus 2. So here restriction is that x minus 2 must be not equal to 0. This implies that x not equal to 2. So in this case, domain will be set of all real numbers except 2. If function is suppose square root of x minus 3. So here restriction is x minus 3 must be non-negative. This implies that x is greater than or equal to 3. So I can write that domain is closed 3 to infinity. And if function is cube root, it is defined for all x, means if I say x equal to minus 2, then minus 2 raised to the power 1 by 3 or 3 raised to the power 1 by 3 all are valid. So it is defined for all values of x. There is no restriction here. So domain I can write set of all real numbers. If function is logarithmic function, it is defined as ln, suppose it is ln x minus 1. Then domain restriction for this function is that inside log it should be strictly positive. So we can write x minus 1 greater than 0, so x greater than 1. So domain I can write it is 1 to infinity. Now if function is exponential function, fx equal to 2 raised to the power x, then there is no restriction on exponential function. So for this function also I can say that domain is set of all real numbers. Now trigonometric function tan x. So for tan x, domain restriction is cos x must be not equal to 0. This implies that x not equal to plus minus pi by 2 plus minus 3 pi by 2 or plus minus 5 by 2 and so on. Or we can write x equal to 2n plus 1 pi by 2 where n is integer, where n is any integer. Now, so first domain for tan x, it will be set of all real numbers except the real numbers plus minus pi by 2 plus minus 3 pi by 2 and so on. Now if we consider one example of mixed function. Suppose mixed function means fx is uh, root x minus 2 divided by x minus 5. So for this mixed function, we need to check restrictions. So here restriction for square root, what is the restriction? And that x minus 2 must be greater than or equal to 0. This implies that x is greater than or equal to 2. Other restriction is that denominator must be not equal to 0. This implies that x not equal to 5. Hence, we can write domain for this mixed function. Domain is x must be greater than or equal to 2. So 2 to infinity, excluding the value 5. Okay. Now, how to find range? Range is defined as set of all output values y of the function or set of all images y corresponding to domain values. There are some important questions related to range. First question is how to find range. So answer is there are some methods called direct method, domain restriction method, inverse method, graphical method. Second question is what is the process of methods? So answer is for direct observation method we try some values of x and observe the behavior of y. In domain restriction method we use restrictions on x to find y. In inverse method we solve the equation y equal to f of x for x and then apply domain restrictions for valid y. In graphical method, this is very simple method. Sketch the curve, sketch the graph and observe vertical spread. Vertical spread means range of y. Other important question is which method for which function. So for polynomial, we can use direct observation method or we can also use graphical method if you can draw the graph easily. For rational functions, if we talk, then inverse method works best. For even root function, best to use domain restriction method. For odd root functions and exponential functions, direct observation method is better. And for logarithmic functions, try to use domain restriction method. And remember, for trigonometric functions, graphical method is easiest. Now let's practice finding the domain and range with some examples. First function is y equal to x square. This is a polynomial function and polynomials are defined for all real numbers. There is no restriction on x. So domain is set of all real numbers d equal to r. It can be written d equal to open interval minus infinity to plus infinity also. Now for range, we observe that Square of any real number is always non-negative. That's why we write x square is greater than or equal to 0. So range is closed 0 to infinity. Also we try y for some x. Suppose x is 0 plus minus 1 plus minus 2 plus minus 3 plus minus 4 and it tending to infinity plus minus infinity, then y is 0, 1, 4, 9, 16 and tending to infinity. So here we see that minimum value is 0 and y tending to infinity. So range I can write that minimum value 0 to infinity. Also using the graphical method, we can talk about the range also. See, this is the graph. So from this graph, we can see that domain x goes from minus infinity to plus infinity. And what about the vertical values? Vertical values, you see that this is the minimum value 0 and y tending to infinity. So range is 0 to infinity, closed 0. Second example is function y equal to 1 by x. This is a rational function. So to find uh, domain restriction for rational function is that denominator cannot be 0. So denominator not equal to 0, this implies x not equal to 0. Therefore, domain is set of all real numbers except 0. Domain can be written in interval form also. Now we find range using inverse method. Given y equal to 1 by x, this implies x equal to 1 by y. Here y cannot be 0 for valid x. So range is also set of all real numbers except 0. We can use graph also to get idea about domain and range. From graph also it is clear that x goes from minus infinity to plus infinity except value 0. Also vertical values, y values, you see y tending to infinity, y tending to minus infinity also, but y is not equal to 0. So here x is not equal to 0, y not equal to 0. So domain and range for this function both are same and which is set of all real numbers except 0. Now example is function y equal to root 4 minus x. This is a square root function, and if we talk about domain, then for square root function restriction on x values is that expression inside must be non-negative. So 4 minus x must be greater than or equal to 0. This gives x is less than or equal to 4. So this is the domain. So we can write domain is minus infinity to 4. 4 is not included in domain. Now for range, we know square root outputs are always non-negative, means greater than or equal to 0. So we are getting y is greater than or equal to 0. Also, as x goes to minus infinity. What about 4 minus x? 4 minus x tending to infinity. 4 minus x becomes very large. So we can say that y equal to root 4 minus x tends to infinity. So here we see that minimum value for y is 0 and y also tending to infinity. So range is 0 to infinity. 0 is included in range. We can also use this diagram. See, we put some values of x. If x is 0, x is 1, x is 2, x is 3, x is 4, and corresponding values we are finding. So for x equal to 4 value is 0, for x equal to 3 it is 1, for x equal to 2 it is root 2, which is 1.4 approximately, and for x equal to 1 it is root 3, which is approximately 1.7, and for 0 it is 2. So from this diagram we see that value of y is 0, which is minimum value, and as x tending to minus infinity, as x tending to minus infinity. What about y? Y tending to infinity. So range is 0 to infinity. Also, using graphical method, we can conclude the domain and range. So here this is the graph of given function, and you can see that domain for this function is x goes minus infinity to this value 4. So domain values are minus infinity to 4. 4 included. So here you can write that 4 included here. And what about range? Range is that minimum value of y is 0 here, and y tending to infinity. So from this graph we can conclude that range is 0 to infinity and domain is minus infinity to 4. 4 included.